information is going to go from the sensory organ, the nose, the eye, right, the ear, whatever it is, right? From that sensory organ, it's going to go from the sensory organ and then go up to the thalamus. Okay? Because thalamus is the sensory relay center of the brain, right? And then from thalamus, it's going to go to gray matter. Okay? The wrinkly part of our brain. The gray matter that first receives sensory information from the thalamus is called primary sensory cortex. In the visual system, it's called primary visual cortex. In the auditory system, it's called primary auditory cortex. But whenever you see primary in front of that, it means, in front of any sensory cortex, it means that this is the first place that receives that information from the thalamus. Primary sensory cortex will then send information to secondary sensory cortex. And now I'm getting too short, right? And finally, secondary visual cortex will send information to association areas. And association areas are areas that receive information from more than one sensory system. So now sensory experience is being integrated, it's being associated, right? I smell and taste this, right? So association areas are areas that are receiving information from more than one sensory system. Okay. So the flow of visual information through our visual cortex follows this pattern. So it goes from eye to thalamus to primary visual cortex. Here's primary visual cortex that we've been talking about, right? And secondary visual cortex is around there, close to it. And then we have two major association areas. Okay? And as we go through this hierarchy, the receptive fields become larger and they become more complex. Okay, so probably, at our primary visual cortex, we have receptive fields that respond to something like this, which we've already talked about a lot. Secondary, now we might have things that respond to something like this, a triangle. So a cell might fire whenever it sees a triangle in a particular part of the visual field. So the receptive field becomes more complex, right? Until the point where you're in association areas, and then you might have a cell that fires whenever it sees something that looks like a chair. Okay? And so we talked about this inferior temporal cortex in chapter 1, or chapter 3, right? We talked about the inferior temporal cortex in chapter 3, and I said, this is important for memory. Temporal lobe is important for memory. And I said, in particular right here is important for object recognition, right? The idea that you understand this is a chair. You recognize that as an object, right? There's certain cells that are going to fire. For you to be able to recognize this, there are certain cells in your brain firing whenever you see a chair. Okay? That's their receptive field for the chair. Okay? So the receptive fields get more and more complex as they go on. So,